Let's take a look at some past paper examples. These are basics. They can get pretty tricky, but let's just start with the basic ones first. So I tried to redraw this, and let's just read what they say. So they say S is a point on PQ. So S is the point on PQ such that PS to SQ, so PS to SQ is 4 to 5. So basically this is 4 parts, and that's 5 parts. And then the total is 9. So that's 4 over 9, and then 5 over 9. Now, with other lines, they usually say that's the midpoint. So that's a half and a half. But in this one, they just kind of wanted to be fancy, and they said, oh, okay, well, this is 4 parts, and that's 5 parts. So it's not really, it shouldn't be more difficult. It's just like saying, okay, it's just a different fraction. It's not like a half anymore because it's not a midpoint. It's a bit off center. Okay, so that's the one part. And they're saying find OS. So they're trying to tell us, or not trying to tell us, they are telling us to find OS in terms of A and B. Now they did give us A, and they gave us a B. Now we want to get directly from O to S. We want to find out what that is, but we can't go directly there because we don't have any information about going directly there. So we have to find a different route. So in the previous video we looked and we said, well, it doesn't matter where I start, as long as I start at the one place and end at the one place. If I take different routes on these lines, it should work out. So unfortunately, I can't go directly from O to S. So I should either go from O to P and then P to S, or O to Q and then Q to S. So I'm going to do both just to prove that they should be the same, but you can only do one, right? So O to S, I'm going to have to go from O to P and then from P to S. That's kind of the route I can take. I'm going to take this away. No problem. No, don't need that anymore. So OP is A. So I know that part is easy. No problem there. That's just typical A. The problem comes in with PQ. Now, well, not PQ yet. So PS, I know, is 4/9 of PQ. Because PS is 4/9. We saw that. 4/9 of PQ. I don't have PQ. But if I wanted to find PQ, if I want to start at P and go to Q, then I'm going to have to go in this direction. I can't go from P to Q because I don't have the actual number values or the actual column vector values. So I can't go P to Q or P to S because I don't have the values. So now I have to say, well, I'm going to write PQ in terms of A and B. So this just comes down for the ride, no worries there. And this 4/9 kind of just stays there. And PQ, I know if I start at P and I want to get to Q, I can take that route, which is in the opposite direction of A. So it's going to be negative A. And it's going to be in the same direction as B. So plus B. And then I can just write this out as A. So I distribute. So this is just kind of expanding brackets. So that's minus, a plus times a minus is a minus, and that's 4/9 of A, and plus 4/9 of B. And then this is just algebra. Basically, 1 minus 4/9 is going to give me 5/9A plus 4/9B. So it is, I know it sounds daunting, but it's kind of just following a little path. It's just following paths and then writing what those paths mean. So let's just prove, I hope I can prove it, but let's say I didn't want to go that route. I don't want to go that route. I want to go this route. So, okay, let's just do the color coding. Then we know that one was that path. So in the blue, I'm going to do something else. I'm going to say OQ. So let's just say I want to go from O to S. And that's going to be OQ. OQ plus QS. QS. So OQ is easy. I have that. That's B. No worries. Just put that in there. And then QS, I know is 5/9 of QP. Sorry about that. QP. B just stays that. The 5/9 just stays that. Now QP is going to be the opposite of B, so it's negative B. And it's going to be in the same direction as A, so plus A. And if I distribute this, I'm going to have B, that's going to be minus 5/9B, and then just plus 5/9A. And these two things, B minus 4/9 is just going to, B minus 5/9 is going to be 4/9 of B plus 5/9 of A. And then I can see here, well, there's 5/9 of A, here's 5/9 of an A, and then 4/9 of B and 4/9 of B. So it didn't matter which route I took, as long as I just made sure that if I'm going in the same direction as the vector, they're positive, or in the opposite direction, they're negative. Cool. Let's take a look at another example really quickly. Where is it? Okay, there we go. So they're giving us a parallelogram. I'm going to just kind of draw it out for me. There we go. And we have O, A, B, C. They're telling us this is P, and that direction is Q. And this is a parallelogram, so I know the lengths are the same and they're all parallel, etc. So OA, okay, those things are given. So they have a little point E here. So E, and we know E is the point on AB, such that AE, which is AE, is 3 parts, and EB is 1 part. So 3 plus 1, that's 4. So that's 3/4 and 1/4. And find OE. So O to E. Unfortunately, we can't go there because I have no information about any vectors. That's just like OE. Okay, I can't write that. So I have to follow the kind of paths that they gave me. And they're asking OE in terms of P and Q. Okay, so I have to use these P and Q vectors. There are 2 ways. You can definitely go O, or let's just write this. If I wanted to go O to E, there's 2 paths. I can go O to C, C to B, and B to E, which I don't want to do because that's like 3 lines and well, I won't say it's a nightmare. It'll just take very long. So I'm going to take the shortest route, which would be OA, which seems to be pretty easy. OA and AE plus AE. I think this should be simple. It's actually easier than the previous one. I should have started with this one. So OA I have, that's just pretty much P. There we go. And then AE is 3/4 of AB. Now I don't really have AB, but I have OC. And I know OC is going to be the same as AB. Because vectors, like we said, it doesn't matter where they are. I know these 2 lines are parallel, and I also know they're going to be the same length. So as a vector, moving from O to C is going to be the same as moving from A to B. So A to B is actually just going to be Q. So I know A to E is going to be 3/4 of Q, and E to B is going to be 1/4 of Q. So to get this AE part, is that AE part, which is just 3/4 Q. Wow, that was so much easier. I should have started with this one. Let's see, there's another example. I don't want to say, let's do one, and then it's so easy. But yeah, that was pretty straightforward. Okay, let's take a look at another one. This one looks a little bit more bulky. I'm not going to draw this over. This seems like annoying to draw. So we have this weird shape. They're saying the diagram shows triangle OAB. So OAB, so that's a triangle. And a parallelogram OALK. So there's a little parallelogram over there. And the position vector of A is A and the position vector of B is B. So that is the origin going to A and to B. K is a point on AB, so that AK and KB, let me just write this with my smaller pen, which I have to find, is 1 to 2. So I know AK is going to be 1 part, and that's going to be 2 parts. So if there's 3 parts in total, so that's going to be 1/3, and that's going to be 2/3. And next they're telling us find the position vector of L. So the position vector of L is basically going to be OL. Okay. So from O to L, there's probably a couple of paths that I can follow. I can do OK and then KL. That seems fairly easy. Or I can do OA, AK, and then KL. In a way, I think this is going to be, the zigzag method is probably going to be a little bit easier for me than OK. Yeah, I'm going to go this route. I'm going to say, again, you can go OB, BK, KL, that's also fine. But this just seems like it's going to be easier. And the reason I say that, because I know OA and KL is actually the same thing. Both of them are just going to be A. So the only tricky bit is finding that AK part. So we'll look into that now. So going from O to L, I can follow OA plus AK plus KL. Okay, so that's kind of the route I'm going to follow. The OA part, it's pretty simple. That's just this A. And then this AK is actually a third of AB. AB. And the other K, this KL part is simple. That's just A again. Okay, so the third of this whole distance is kind of relevant because from A to B, I can use these vectors A and B. So this A just stays there, just coming down for the ride. This third is there. So A to B is actually, if I want to go from A to B, I'm going to go in the opposite direction of this vector. So it's going to be negative A. And I'm going to be in the same direction as B. So plus B. And then that's just plus A. Okay, so if you wanted to do, well, we'll do the other route as well. But for now, we'll just quickly do this and we'll see we get to the same place. So this is A. This is going to be minus a third A. That's going to be plus a third B. And then that plus A just comes along. So basically I have an A plus an A, which is 2A. And then 2A minus a third. So I'm just going to say, well, that's going to be 2A is 6/3, right? Because that A is 3/3 plus that A is 3/3. And then I'm taking off a third. So I'm going to be left with 5/3A. It's just like easier to write like that. Plus a third B. So let's take a different route and then we'll see if we get to the same thing. Hopefully we do. So for the next one, let's just do, I don't know if I'll have enough space, but let's just try. Let's say I'm going to go OL is going to be OB. So I'm going to go up and then I'm going to go plus BK, and then plus KL. That should be fine. So OB is easy. That's just a B. No worries there. BK is 2/3 of BA. 2/3 of BA, and then because of that 2/3 part there, and then KL is just A. Again, because it's a parallelogram, so that part is going to be the same as that part. Okay. So the B part, and then the 2/3. So I know BA, if I wanted to start at B and end at A, if I wanted to use these vectors, I have to go negative B plus A, but I'm not going all the way from B to A. I'm actually just going 2/3. That's why I'm going 2/3 of the whole way, and then plus A. Sorry, this shouldn't be an equal, that's a plus. Okay, so then there's B, and that's minus 2/3B. Okay, and then plus 2/3A, and then plus A. So fingers crossed we get it the same place. B minus, so 1 minus 2/3 should just give me 1/3 of B. And an A plus 2/3, that's 1 and 2/3. So 1 and 2/3 of A, but 1 and 2/3 is the same. So 1 and 2/3 is the same as 3 times 2 is 5/3. So if I look at this, then let's just see. I got the 1/3 of B, which I got there. And the 5/3A is the same as 1 and 2/3 of A. So you see we got to the same point. You obviously don't have to do both. I just wanted to prove that you can follow either route, and you'd still get to the same place.